Hey guys, welcome back to my channel Success Engineering Official. I'm back with a new video. So today we are going to estimate the load calculation for VRF project. You seen I have already made a video for the VRF project designing in my previous tutorial. If you not seen still, I will give the link on the description box. Please go and watch that video. I have already done the G+5 project for VRF system. Today we are going to learn how to estimate the load, cooling and heating load using HAP software for VRF project. So before I start this video, I would like to request you guys, please do subscribe my channel and hit the bell icon as well, so that you can get the notification of my upcoming videos. So let's start now. Let me open, first of all you can see this is a layout, floor plan layout for G+5 building, G+5 floor. For the same building I have already designed the VRF project. So this is the first floor. First we have to do calculate the load for the one floor, and similarly you have to calculate the for other floor also. So let's start now. Let me open this HAP software. This HAP hourly analysis program 4.9. Okay, so you have to cancel this. First of all, everything you have to cancel. Okay, so this is your HAP software. Okay, HAP 4.9. So what you will do, first of all, click on project, take new, and then you have to set here in general. You can see here there are two tabs, general tabs and project tabs. So first of all, go to the general, and you can see here this measurement unit. So there are two unit system here given, English system and metric system. So we have to select any one as per your flexibility. So I am selecting now English system, and you can give here the career sales engineer email ID, and you can see here in the next preference applying to the HAP. So toolbar and status bar here, show tool tips, show date and time. Okay, and the next here right side, operating mode and enable energy analysis feature. So we don't want to enable this, simply uncheck. And next, go to the next tab, project. So you can see here ventilation standard. So we need to select any one standard here, ventilation standard ISRA 62.1 2007 or 10, anyone. And next one is energy standard. So in this energy standard you can select the energy standard 90.1 2010, and this is for electrical side, lead 2009. And this is the currency. So we are designing for the UI project. So here in the UI, Emirates dirham is Abu Dhabi Emirates dirham. Okay, AED, this currency for UAE is AED. Okay, and simply click OK. Then what you will do, you can see here this is untitled. So simply right click and go to the properties, and you have to provide the project name. So we are calculating for VRF project, VRF project, VRF project G+5. And number is something you have to provide VRF 001, and date is for the today date, already automatically, contact name, and then all the information you have to provide, and simply click OK. Then it will appear here. You can see before it was untitled, now it will appear here VRF G plus VRF project G+5. Next step is you have to click on this weather, and this list view, double click on the weather properties, then you have to provide the weather. Now you can see here, this is the weather properties. Okay, so the design parameter, there are so many tabs also here. So first of all, you have to go to the design parameter, and you can see here there is region. You can select the region here as per your requirement. So I am selecting the Middle East because we are designing for the Middle East, and the location is UAE, United Arab Emirates, and city is Dubai. Okay, or Abu Dhabi. We are designing for Abu Dhabi. Let's say Abu Dhabi. So here is Abu Dhabi, and all the parameter automatically filled by software because it has been taken by software. Okay, or already inbuilt. So latitude for Abu Dhabi is 24.4 degree, and longitude is minus 54.7. Elevation is 88 feet, and summer design dry bulb temperature is 1111 degree Fahrenheit. Summer design wet bulb temperature is 74, and daily range is 23, and winter design dry bulb. Winter dry bulb temperature is 52 degree Fahrenheit, and winter constant wet bulb temperature is 43.6. And remaining value and parameter should be same, so do not change the remaining parameter. Simply click OK. Okay, so this weather property is already set. Next, what you will do, go to this project library. So you have to create first schedule. Okay, so click on schedule and double click on this list view, tree view. So simply create here schedule. So we have to create the people schedule. People, simply type here people, and then schedule type fractional, because people is comes under fractional. So you can see here fractional, people, lighting, equipment, this all are comes under people fractional. Okay, so simply click here, check on fractional. Then you have to go to the hourly profile. So simply click on first profile. You can see, if you select here, you can set as per your requirement, as per your timing and all. Okay, so for the safe side, you have to select 100% each and every things. Okay, each and every column you can select 100%, just for safe side. Okay, and then assign, go to the assign and simply select all, then click on profile first, and okay. Next schedule is simply right click on people schedule, duplicate it, and next schedule is lighting. So simply type here lighting and click on fractional, then go to the hourly tabs, simply select, and simply go to the assignment, then select profile 1, click OK. Again right click, duplicate, and now this time we have to create equipment schedule. So equipment, click on fractional, then hourly profile, select first profile, go to the assignment, select all, click OK. Now the last schedule is thermostat. So TS, and thermostat comes under here fan thermostat. Okay, so simply click fan thermostat, then hourly profile, select all January to December, and select one. Okay, so your schedule is created. Now you have to create the U value for the wall. So simply click on wall, double click on the new wall, then you have to go to the drop down and select your medium weight wall. Okay, and outside surface color is dark because the dark color is absorbing more heat. So we are, for the safer side, we are selecting the dark, and observability is changed automatically here. See, if you select your medium, then observability is here 0.675. If you are selecting the light, then it is going to be decreased. That means this is the observing the light, is observing sunlight observation. Okay, so for safer side, we are selecting the dark. Okay, now the things is here, what you provide U value. Okay, so outside wall, have to rename outside wall. Okay, So for the U value, already this U value is actually taken from the civil people. Once you are doing the project, then you have to request the U value from the civil people. So how it looks like, I will show you. Actually, I have this Excel sheet, and this is given by civil team, civil people. So we have to request the U value because this is civil side. So you can see here, this is the U value for the external wall. The total overall U value is 0.089 BTU per hour degree Fahrenheit square feet hour. Okay, so 0.089 for the external wall. Okay, so this is the outside wall, external wall is 0.089 BTU per hour degree Fahrenheit, BTU per hour degree Fahrenheit square feet. So 0.089. So you can see here, this first layer is 1 inch outside surface resistance. Okay, density is 0. So what you will do, simply here outside surface resistance is 1 inch outside surface. So this is the last one, 1 inch outside surface resistance. So thickness is 1 inch. Thickness is 1 inch here. What you will do here, you have to simply type 1 inch. It is set already, so you cannot change this. Okay, so next layer is 0.5 inch plaster cement. Okay, 0.5 is 0.5 is nothing but the half inch gypsum plaster. Thickness is 0.5. Density, so density is given here. You can see here, density is 116.250. So 116.250. Next is a specific heat. So a specific heat is not given. I think here a specific heat is not given. So leave that one as it is. And next layer is R value. So R value is given here. You can see here, this is the R value 0.1. So a specific leave as it is, and R value is here 0.1. Okay, so 0.1. And weight is automatically taken by software. So 4.8. Here is 4.8. You can see here. Same. Next layer is 8-inch concrete block with polyester insert. Okay, so what you will do, we have to simply rename this concrete 8-inch concrete block. Okay, so 8-inch concrete block. Okay, so here the thickness is 8 inch, so simply type 8, and density is equal to 84.375. 84.375, and specific heat is 0, and R value is 10.128. Okay, so 10.128, and weight is, you can see here, 56.3. So it's same, 56.3. Okay, weight is automatically calculated by software. Once you provide this thickness, it will calculate automatically. Okay, so next layer is 0.5 inch plaster cement. So 0.5 inch plaster cement. So what you will do, simply type here 0.5 inch plaster. Here thickness is 0.5. Density is 116.250. So 116.250, and a specific heat leave as it is, and R value is given here 0.1. So it will be 0.1. Okay, and the weight is already here 4.8. So you can see here, this is the weight is 4.8. Okay, so this next layer is 4 inch face brick. So it's not applicable. So what you will do, simply right click and remove it. Okay, so you can see here 0.088 is approximate 0.089, approximate same. So simply click OK. So this is your transfer function coefficient could not be generated for this assembly material layer. This problem occurs when overall thermal resistance of the error. This is the error. Therefore, the construction of this assembly must be revised so its overall thermal resistance acceptance fall within the more or normal range. So in this case, what you will do, this software is not taking this one. So in this case, what you will do, simply cancel this one and double click. Now what you will do, simply select again medium wall, and in this time simply select the layer from here. Okay, I have a gypsum board, and then here is space. Then this value, what you will do, simply adjust these values. So how to adjust, you have to q is equal to u is equal to 1 by r. Actually this formula is u is equal to 1 by r. So you have to increase the r value, so this u is automatically decrease. So what you will do, increase the r value simply. Okay, increase the r value, so you will get a u value. Okay, so 0.06, we need 0.08, 5, 0.05. Okay, so this also 4, 0.056, 2. Okay, 0.09. Okay, it approximates same. Now click OK. So your u value is set, and next is create the u value for the roof. So simply double click here on the roof, and the roof u value is here 0.08, approximate same. You have to increase the r value and bring the value similar to 0.05. Here is 8. Okay, so 0.07. Now take 7, 0.06, make it 6, 0.07, make it 5, 4, so 0.08. Click OK. So simply adjust the r value, then you will get the u value. Okay, of overall u value. Now next is, if there is any window or door, check in the drawing if there is window or door outside the perimeter. So there is no window and door. So in this condition, what you will do, there is only one door here, single door. for the corridor. This exposure, this exposed door and window. Okay. So in this condition, what you will do, consider this door. So in this condition, what you will do, simply click here on the door, double click, and make this door name is D1, and gross area is, consider the width of the door is 3.5 and the height of the door is 7 feet. Okay, so 24.5 square feet, approximate 24.5 square feet, and U value is keep as it is. Simply click OK. Actually, this door and window, wall, everything U value is given by civil people. So take from the civil people and directly enter in the software. You will get the overall U value. Okay. So this schedule already created a view value for the wall, door and roof already created. So next step is space. So go to the space and create the space. Simply click on this list view and double click on tree view, and now create the space. So you can see here this is the space properties by default. So first option is there are so many tabs here. So simply click on the general tabs and provide the name of the space. So what we will do, we are providing here the office first. So office 1, the first space is office 1. So simply provide the name here, space name office 1. Okay. Floor area is given, so 50 square meter. Okay, so simply convert into the square feet. So 50 into 10.76, simply multiply into 10.76, so we will get 538 square feet, and average ceiling height is assume 9 feet ceiling height. Okay, and building weight is 80 pounds, medium. Okay, simply for the medium building 80 pounds. Okay, and here for the ventilation requirement is nothing but the fresh air requirement. So outdoor air, so this is comes under office. So this is office space. So simply select here space, office space. Okay, so this one office space here. Okay, so you can see here the outdoor air requirement is 5 cfm per person and 0.06 cfm per square feet. It is taken by software from this standard. Okay, space usage default as standard 62.1 2010 as you select in the beginning. It is same. So now go to the internal tab and you can see here this is overhead lighting. So what types of light? So this is unvented light, and lighting wattage is 1.2 watt per square feet actually we considering, and schedule you can select the lighting, and the equipment is 1.4 watt per square feet is taken for the office. This is from the ASRE actually, and now select the equipment. Okay, and number of people is 2 for the office. We are generally considering an office work. And next is select the people schedule, and this miscellaneous load is nothing but the load from the other equipment, like this is applicable for the kitchen. Okay, so leave this as it is and then go to the wall. Okay, so you have to consider the exposure. So in this orientation is not given, so in this condition what you will do, you have to assume the orientation. Okay, so this is north, south, east, west. So this room is comes under this this is north, south, east and west. Okay, so check the exposed wall. So exposed wall is this is north, south and east. Okay, so south and east wall. So simply select here exposure south and east. So wall gross area, so we have to consider the wall gross area. So simply check the wall length from here to here. You can see here 8.5 meter, and height is 9 feet. Sorry, this is the east wall. So east wall 8.5 meter. 8.5 as 8.5 into height of the wall is 9 feet. Okay, 8.5 meter. 8.5 meter convert into the feet. 1 meter is equal to 3.28 feet. Okay, and then multiply into height. So 250 square feet. Okay, and there is no window and no door, and wall is medium weight wall, and east side, actually this is 250 for the east side. Okay, and south side is, check this one, so DLI, here you can see 5.8 meter. Okay, so simply convert into the feet. So 5.8 into 3.28, 5.8 into 3.28 into 9 feet. Okay, so 171 square feet. 171 square feet. Okay, now next is roof and skylight. So simply select here H. H is nothing but the horizontal roof, and roof cross area is similar to the room area, because the whatever the room floor area is the same roof area. It will take automatically, otherwise you have to enter here. Okay, next is infiltration. So they assume this building is tight construction, so do not provide this. Go to the floor. So now in this here you can see here there are four options: floor type, floor above. First option is floor above condition space. That means the floor which you are designing is above condition space. That means the below floor is condition. And second option is, if you are selecting the second option, so floor above unconditioned space, once you are selecting this, there are so many options here, because if there is condition space, so no need to provide anything, because below is AC and up is AC, so temperature is similar, so no need to provide. And third one is slab floor on grade is nothing but the floor is on the grade is nothing but on the directly on the floor. And the last one is slab floor below grade is nothing but the underground. Okay, so in this case, in our case, this is first floor, and this is the parking. That means this is unconditioned and this is condition, because below floor is no condition. So what we will do, we have to select this second option, floor above unconditioned space, and the floor area is 531, and u value of the floor is 0.1. For example, assume 0.1, or you can check from here. This is for the partition and roof, wall, and this is for the partition. So you have to keep as it is, because this is from the civil side. So point 1, unconditioned space maximum temperature. That means the first you have to provide the ambient space maximum. That means the maximum ambient temperature. Okay, so what is the ambient temperature? 111. And unconditioned space maximum temperature is nothing but this is a less than 5 degree from the ambient. That means 111 is your ambient temperature maximum minus 5 degree. This is your unconditioned space maximum temperature 106. Unconditioned space minimum temperature or ambient space minimum. That means unconditioned space minimum temperature. So there is one formula I will show you. I will show you this how to calculate that one. So Let me open a Word file. Microsoft Office, then Word. Okay. Okay. So unconditioned space ambient space minimum. That means ambient space minimum. You have to first found ambient space minimum. Okay. Actually, there is a formula for the range. I will show you. Range is equal to unconditioned space unconditioned space unconditioned space max minus unconditioned space minimum. Okay. So unconditioned space minimum temperature equal to unconditioned space maximum minus range. That means you need to calculate unconditioned space minimum. Unconditioned space minimum is equal to range minus range minus unconditioned space maximum minus range. Okay. So unconditioned space maximum temperature. Unconditioned space maximum temperature is 106. Okay. So you have to type here 106, and daily range you can calculate from this software as climatic data software. Simply select here Abu Dhabi, and then daily range you can see here for the summer. This one 23. So here is 23 daily range. So it will be 106 minus 23. 106 minus 23. That means 83. 83. 83 degree Fahrenheit. 83 degree Fahrenheit. Unconditioned space minimum temperature 83 degree. Unconditioned space minimum temperature is 83, and unconditioned space ambient space is 55. Ambient is more than 5 degree more than this one. Okay, so 83 plus 5, what will be 88. So this is how you calculate this unconditioned space minimum temperature. Okay, and next one is, you can see here the infiltration floor. Okay, and next one is partition. So you have to check is there is any partition here or no. You can see here there is no partition because here is AC and this room is AC, so there is no partition, and this is exposure. So leave this as it is. Click OK. So your space 1 is ready. Okay, next one is office 2. So you have to create for this space also. You need to create each and every space. So for the office 2, what we'll do, simply right click and duplicate. Simply provide your name office 2, and the area is the area 41.8 square feet. So 41.8 into 10.76. So 449, 450, approximate 450, and height is 9 feet, and office space. Next go to the internal, everything is same. here is same everything, and exposure, so here is only south exposure, so simply click here not use, and south exposure is 171. Okay, check this one. Please check this south exposure 5.8, that means it will same. Okay, so 171, and here is roof, so roof is 450. You can see here this is the floor area, that means the roof area is also same 450. And horizontal is nothing but the flat roof. Infiltration floor, above unconditioned space, so floor area is 450, and everything this remaining is same. And now partition, so there is a wall partition, as you can see here. This is your lobby area, that means there is no AC in this, so you have to consider this as a partition. This must is your partition, so 3.7 is your partition. That means you have to calculate 3.7 meter into 3.28, convert into feet into 9, height of the wall, so 109. Here is 109, and u value for the partition is 0.5, and this is your 1111, and unconditioned stress maximum temperature is 106. Here is 106, and ambient is this much, and this is 83. Unconditioned stress minimum and maximum is 88. Simply click OK. Okay, so you have created the second space also. Now next is office 3. Office 3 is 67.6 square feet. So for office 3, simply duplicate this one, right click and duplicate, and rename this office 3, and floor area 67.6. check here once again, 67.6. okay, so 67.6 square meter into 10.76, so 727 square feet. 727 square feet, and 9 feet is the height of this, and internal is same. Here wall is nothing but your exposure wall is north wall. So check the length of the wall, type DLI and check this length, so 6.5 meter. That means 6.5 into 3.28, 21 meter, 21 square feet. 6.5 meter, 1 meter, 3.28 feet, so 21 feet into 9 feet, so 192. Here is 192. Okay, and remaining is same, and roof is here 727. So 727 is your roof area, rental roof. And infiltration is nothing, floor is above 727 floor area, so 727, and this remaining value is same. Partition, so check there is any partition of the, so there is partition. You can see here this is your toilet, so no AC in this toilet, so this whole wall is partition wall. That means 9.95. so 9.95 meter into 3.28 feet into 9, so 293. Here is 293 wall partition. Now click OK. Next office 4, so duplicate this one and check here office 4. Office 4 is also same because the area is same, so office 4, simply duplicate this one and rename it office 4, and remaining is same. Internal is all will be same, no change, because exposure is also north exposure, and area is same. infiltration, and here is 0, and here is also same. Partition is 0 because there is no partition, so click 0 and OK. Next one is Office 5. This is the Office 5. We have to create, duplicate, and rename it Office 5, and area will be same, everything same. Here is also same. Partition, there is no partition. Okay, so Office 5, and next one is here Office 6. So Office 6 is 72 square meter. Okay, right click, duplicate. Office 6 72 square meter. So 72 into 10.76, 774, 774, and remaining is same. Internal is okay, and exposure, so exposure, check the exposure here. North and this side is north, south, east, west, so this is comes under northwest. This is west and this is north, so this is northwest. Okay, so simply select here north, and this is northwest. So north exposure is LI check from here to here 6.4, and this is you have to check angular dimension, angular line 3.8, 6.4, 3.8. So 6.4 into 3.28 into 9, so 188. Here is 188, 3.8, and next one is 3.8, so 3.8 into 3.28 into 9, so 112. Okay, this is your exposure. And roof door horizontal floor is 774, here 774. Filtration floor, slab floor on grid, and here is 774. Floor area and partition, so there is no partition here, so there is no partition, it will be 0. Okay, you can see here already calculated. Now the last one is corridor, so check for the corridor also. So 19.6 by 1.6 area, double click, and here space is corridor. So corridor is 19.6, 1.6, 19.6 into 1.6 square meter into 10.76, 337 square feet. 9 feet is the height, and here is, you can select here lobby. Okay, so this is comes under lobby, and internal, this is internal, everything is same here. Lobby number of people is 0 because there is no people in the lobby, and wall, there is no exposure also, so I think here is exposure, or this is AC room, so no exposure. Okay, so no exposure, and here is horizontal roof. So what is the area? 337. Here is 337, and next one is infiltration floor, slab floor on grade, slab floor, floor above unconditioned space, so 337, and partition, so there is no partition, simply click OK. So you can see here this all space is created. Now the next one is next and final step is system. So we need to create the system. So up to this point is same for each and every system, either it is packages, VRF, split or whatever, chill water, whatever. So these the step which I have done until now is weather properties and schedule and u value, everything, space, everything is same for each and every system. Now the next step will be vary as per the system. So simply click on the system and double click on the preview. Now you have to provide your system name. So VRF001. Okay, and then equipment type is, you have to select here terminal unit, and air system type. Air system type is nothing but VRF. Okay, so variable refrigerant flow. Okay, VRF. And number of zone. So you have to divide, the VRF is always divided by zone wise because it is controlled individually. As you can see here, I will switch on this system. So this for this AC there is thermostat. Each rooms, each office there is thermostat. So this indoor unit is controlled by individually. That means there is zone. This is 1 zone, 2 zone, 3 zone, 4 zone, 5 zone, 6 zone. So there are 6 zone in each space. That means zone is refers to thermostat, and this is a VAV system. That means this is controlled by individually. So in this office, the office people want to control the temperature, so it will control. For example, this room 24 degree. If these people want to control set 24 degree, so he can set 24. If you want to set 20 degree, that means he can set as per his desire. So this is a called zone. Okay, so 1 2 3 4 5 6 zone are there, and 7 zone. So number of zone is 7 here, and here is 7. Okay, direct ventilation. And now go to the zone and component. So you can see here the your all space is here visible, and this is the zone. So zone 1, office 1. Okay, so you have to add the space in the zone. Okay, and click on next. So zone 2, office 2. Simply add and click on next. Zone 3, office 3. Add, click on next. Zone 4, office 4. Next. Zone 5, office 5. Next. Zone 6, office 6. Next and final a zone is corridor. So simply click, add, and now go to the thermostat. So set this one thermostat. So cooling thermostat set point. So 75 degrees the comfort, and it is unoccupied. So it will be same. And here is heating. Heating also taken by software. If you want, you can change or do not change this one. Okay, and this is your throttling range is the difference between two, so it will be 5. And next is here, simply select the thermostat schedule. Now go to the common data. So common data is cooling. So you can see here the first is cooling coil. Design supply temperature. So supply temperature is keep 56 degree Fahrenheit. That means 13 or 12 to 13 degree centigrade, and coil bypass factor is 0.12, and the heating is 95 degree. Okay, and fan control is fan on. And next is terminal unit. So terminal unit you can see here for zone, and terminal type is fan coil. That means the indoor unit, fan coil type FCU. And total static is do not enter this, leave as it is. And now go to the sizing data. So sizing data you can see here, this is for the chilled water system hydronic sizing specification. That means if there is chilled water system, this is applicable, otherwise it leave as it is. And here is safety factor. So cooling sensible is keep 15% and latent heat is 10%. Okay, and everything is okay. Now click on OK. So your system is created. Now simply click on save, and here is VRF project G plus 5 save. Invalid project name. So what you will do, G plus 5. Click on save. Okay, so your project is saved. Now the last point is only report. So simply right click and go to here, print view design result. The result, your output result is generating now. And now you can check here whatever which report you want to simply check here. So first one is in system sizing summary checked. I want system sizing summary, zone sizing summary, and then zone load summary. Okay, and simply click on preview. So your report is generating now. Just wait, it will take time. Okay, so this is your report. Oh, I want to save this one and the desktop. System design report. That means this is the output report. Output report. Okay, I'll simply click on desktop save. Okay, now we have to open on the desktop and we will see. Simply double click. Okay, so this is your output report. So how to read this? You can see here this is project name VRF project G plus 5 IG provided and prepared by SEC is nothing but success engineering consultant. Here system sizing summary VRF 001 today date and time is given. And here is you can see here system information which you have provided. Here system name VRF 001, class terms, and here system type is VRF, and number of zone is 7, floor area is nothing but the total floor area 4280 square feet, and location is Abu Dhabi, Dubai. Okay, and the calculation sizing calculation information is calculated for the month of January to December, and sizing data is calculated. And next one is you can see a zone sizing summary. This is the zone sizing, and this is the air system sizing summary. This is zone sizing. So in the zone sizing, the zone and the data is given from the each zone. You can see here the zone sizing data. Zone 1. Okay, maximum cooling sensible is 13.9 mph. 1 mph is equal to, you can see here 1 mph is equal to 1000 BTU per hour. That means 13.9 into 1000. So this is in BTU and divided by 12,000. You will get in the tonnage. So 1.15 ton for this zone 1. Okay, and design airflow is 682 and maximum airflow is 6. And this is a heating summary. Heating load is 1.5 mph, and this is the area, and this is the CFM per square feet. For each zone is cooling load is here, and this is the heating load. Okay, and this is terminal unit sizing data. That means this is for the sensible and total coil load, sensible and entering dry valve, wet valve, everything is given here. And this is for the heating, and here is a space load summary. Okay, so this zone 1, what is the space? So zone 1, you can see here zone 1 office 1, and again this is the cooling load, airflow, and zone 2 every. This is the space load which we have created, and this report is here system design load summary. Is for this design load was what you have provided. Okay, the row, wall, all the information is given here. and the last one is system psychometric for VRF. This is psychometric data. Okay, so how it's looks like, how to create. I hope you learn how to create the heating and cooling load calculation using HAP or VRF system. Okay, next report, if you want to create any other report, for example space, if you want to create the space report, for you want to know what you have entered in this space, so simply select and right click, or there are other option here, you can see here, you input design report, so you can see here. See, as you can see, this is the space and this is office one, space area, ceiling height, everything is given. Outdoor air requirement, this is the wall, window, electrical data, peoples, everything is given here. And next is, if you want to create here input report, so this is your input, simply right click or click here, print input data, or simply click here, you will get this input, what you provided, what you entered. This is your input data. Okay, so I hope you guys you learn how to design and create for this cooling and heating load calculation using HAP or VRF system. So thank you for watching my video, and once again I would like to request you guys, please do subscribe my channel and hit the bell icon to get the notification of my upcoming videos. So thank you for watching my video. Thank you. Bye bye.